This session is a summary of the history of the atom. In this session, you're going to be able to name the scientists who discovered key findings about the atom, and by the end of it, you'll be able to describe how atomic models developed over time. Common questions are comparisons between models and about which scientists produced which models. In the 1800s, John Dalton began work on his solid sphere model. Now, before him, the Greeks had looked at a term called atomos, meaning uncuttable, and they had thought that atoms can't be divided any smaller. This was a view that John Dalton shared. He said that atoms are solid spheres. He also said that all atoms of the same element are identical to each other, which is true. He also said that compounds are formed when two or more different types of atoms are joined together. Again, that was true. That term that he came up with, where atoms are solid spheres that cannot be broken down into anything simpler, we now know is wrong with the discovery of protons, neutrons, and electrons. The next big discovery was by J Thomson. We call this the plum pudding model. In Thomson's plum pudding model, the whole atom is positively charged, with electrons dotted around randomly, like plums in a plum pudding. He discovered it in this way. He fired a very high voltage beam at low pressure, and he noticed that some of the particles were being attracted to this positive entity. So what had happened is attraction. So he technically discovered the electron. The electron was the first subatomic particle to be discovered, and it was found in 1897. You will be asked questions about the plum pudding model structure. You need to know that there's no empty space. So technically, nothing can go through this. There's also no nucleus, if you notice, okay, because the whole atom is positively charged with electrons dotted around. The discovery of the nucleus is sometimes attributed to Ernest Rutherford, but it's actually Geiger and Marsden who done this experiment. They fired positive alpha particles at some gold foil. Now, if the plum pudding model was correct, they wouldn't have been able to pass through. But what they noticed is that the majority of the particles went right the way through. Some bounced back, and some were deflected. The bouncing back showed that there was something that's in the center that's bouncing these things back. The deflection showed that this central thing must have been positively charged, because it wouldn't repel otherwise. What they'd actually discovered is the nucleus. And this was what Ernest Rutherford used in his model. Through working with Geiger and Marsden, Rutherford had found that the nucleus was in the center of an atom. He was the first person to propose this. He also said that electrons orbit the nucleus. We come up with this model here called the nuclear atomic model. Now, this model is different from the plum pudding model because there's loads of empty space, and the nucleus at the center is very, very small. So things can pass right the way through this structure. He had also discovered the proton in his work on this. The proton was discovered in 1920. Niels Bohr done some more work on Rutherford's structure. So he looked at Rutherford's model, and he had excited some electrons. Now, what he found is that the electrons jumped a certain distance. The distance they jumped we now call shells. So what Bohr had found is the shells in the structure. So at this point, we have a positive nucleus surrounded by electrons which are found on shells. Bohr's discovery of the shells allowed us to look at how much energy is given out when electrons are moved from one shell to the other. In 1932, James Chadwick discovered the neutron. The structure looks pretty much what we're used to right now. So the nucleus in the center contains protons and neutrons. Electrons were found on shells around the nucleus. What James Chadwick had also found is that the neutrons had the same mass as a proton, but they didn't have a charge. So the whole atom is in balance.